Thank you for the very kind invitation first to this really cool event. So we are a systems research group at Karlsruhe Institute of Technology, and today we want to talk about how we use coreboot and Dasharo in our research. But first, let us introduce ourselves. My name is Yusuf. I'm currently a second-year PhD student here with the operating systems group at KIT. And I'm currently working on various topics around power management and storage technologies. Fabian, do you want to introduce yourself?
I hope everything is working. From me as well, thank you so much for the invitation and for all the interesting presentations and discussions that have already happened. I'm seeing just now poor connection quality, but I hope everything is all right.
Fabian, can you perhaps make your microphone a bit louder, increase the gain?
Yeah, I also am having hard time hearing you.
Yeah, 1 second, please.
It's
that's
better
perfect.
now. Better now?
Is it working now?
No, not anymore.
Oh no.
Now it's
Okay,
better.
now it's good.
Oh no, I think it's the connection quality actually. I'm struggling with my internet. Yeah. Okay. Anyway, let's hope it works. Yeah. Please interrupt me if anything is broken. Anyway, so thank you so much for the invitation and for all of the interesting presentations and discussions that have already happened. So my name is Fabian Meyer, and I recently finished my bachelor's degree with a thesis about a novel mode of system suspend that uses firmware to persist main memory. And afterwards, I worked with Yusuf to make coreboot run on a previously unsupported Eaglestream or Sapphire Rapids board, and both of which I will get into in a few minutes. And I'm currently doing job interviews in case anyone is interested to talk after this event.
All right. So let's talk about firmware, or more particularly firmware in research. So most of the research that is happening in the firmware space focuses on security aspects, and very rightfully so, because we all know that firmware level attacks can be absolutely devastating for your data. And firmware rootkits are kind of the most intrusive malware that you can have in your system, and it's also quite difficult to catch. And just this year, we have already seen two quite serious examples for firmware vulnerabilities, one being logo fail, which I think was mentioned before today by someone, and the TPM GPIO fail vulnerability. I guess you all are familiar with them, so I'll not go into the details here. But the question that we want to ask today is, what else can we do with firmware that is not security related? So firmware also plays a vital part in other areas where the operating system is also directly involved. For example, we have ACPI, which is used to share important power management information and mechanisms with the operating systems. And then there are suspend mechanisms that are also partially implemented directly in firmware. For example, on x86 platforms, suspend to memory is implemented by jumping into system management mode. And recently, persistent memory technologies have also introduced the concept of persistent CPU caches, which again requires firmware support. For example, there is Intel Optane with its eADR technology, or more recently in the new Compute Express Link standard, that's what they call global persistent flash. But that's something I'll talk more about later on. So let's get creative with what we can do with open source firmware. And first, Fabian will show you the initial exploration he has done in his bachelor's thesis last year.
All right. So I would like to talk a bit about my bachelor's thesis. And the goal in that was to take a look at traditional or, well, current modes of system suspend So basically standby, saving power. I think I found the problem. My microphone is adjusting itself automatically. I don't know why, but I hope it will be all right. Either way. So yeah, I was talking about that we were implementing different modes of system suspend. And we used firmware in that to perform completely custom logic during power state transitions. So we implemented it on real hardware within coreboot, within Dasharo. And we aim to reduce the power consumption, of course, but while also keeping the wake latency minimal, because obviously you don't just want to save power if the device then suddenly takes half an hour to turn back on, right? So suspend to memory or S3 usually would save quite a lot of power, but and while also being fast. But if you want to save even more power, basically all of it, you would have to use something like Hibernate or just shut off your device entirely. But that introduces more wake latency. So this was an interesting idea to combine both aspects, and we did this with the design as follows, where we intercepted the ACPI suspend entry request by the operating system, which just performs a regular S3 sleep system management interrupt. And this obviously gets us into the firmware system management mode. And inside of that, we copy the entire DRAM contents to a custom Intel Optane-based memory device on which the DRAM contents are then persisted. So as a second step, we are able to power off the device. So we perform a transition to ACPI S5, not S3, to turn the device off. And then on the next boot attempt, we can, inside the firmware, perform a copy in the reverse direction, back from Optane into the DRAM. So restore the memory contents and then jump back to the operating system wake vector like we would for S3. So the operating system on the other end sees just a regular ACPI resume. And yeah, just want to say that Dasharo made it really easy to get started on a supported board. We used the MSI Pro Z690A. However, of course, the flash chip on the board is not socketed, and we were messing with the boot process of the system, so a few difficulties were bound to happen. But we managed anyway. Yeah, on the next slide, you can see some of the results that we obtained during the evaluation. And those are actually really promising with this approach. We see that our suspend mode has a better energy efficiency than S3, so suspend to memory, after just 1 hour of the device being suspended. The energy efficiency in this case is, well, the overhead of performing the copy, which is obviously a new operation that is not performed in S3. But then this is offset by the zero power consumption, or almost zero, while being powered off. And still, we see an acceptable wake latency in this case, where I have to say that most of the time and hence energy is also hardware overhead due to the specific hardware used. So both metrics can likely be cut at least in half, I think. So why was it a good idea to do this in firmware at all and not on the operating system kernel level? Well, first of all, the implementation is completely transparent to the operating system, which does not need to know at all about the device's capability to perform this type of suspend. But most importantly, it allows it to be competitive with suspend to memory in the first place. If we didn't implement it in firmware, but in the operating system, we would have to execute more parts of the firmware and the bootloader and also the operating system at which point we are finally able to restore the main memory. So doing it in firmware allows us to skip these parts and be quite a bit faster, at least in the theoretical design. Right, so after the thesis, I worked with Yusuf on making coreboot run at all on a different mainboard by ASRock Rack. This is the SPC741D8 mainboard. And this one has, compared to the MSI board, a few additional features that are quite interesting from a research perspective, especially regarding storage via Compute Express Link. And this board is also using Intel's EagleStream platform with a Sapphire Rapids Xeon CPU. And also what makes this board quite nice is utilities such as a socketed flash IC. And we are also not restricted by Intel BootGuard or the platform firmware resiliency, which we've heard a few things about before. But from our perspective, this is actually a difficulty that can arise. And in fact, the first board that we tried did not allow us to flash custom firmware. So this not being present on this particular board is quite an advantage for our use case. Now, the first upstream patches of the port that we performed are already submitted to the coreboot project. And as far as I can tell, this was the first port of coreboot to this platform with full 64-bit support, no less, for a board that is not prohibitively expensive for researchers to obtain. So this is quite nice, in my opinion. And I'm kind of shocked, but also very glad that it worked out. However, there were, of course, a few challenges as well that we encountered. And probably these are well known in the community. But I wanted to talk about this and maybe discuss with you potential solutions for researchers like us. Well, mostly the problem was that datasheets were unavailable entirely or perhaps confidential, which is problematic as well because we wanted to upstream our port, and this would not have been possible with using confidential NDA documents. So we were quite restricted in the methods we could use to perform the port. And then secondly, we struggled to get any debug output from the board whatsoever, especially in the first stages, but also for months, we didn't get any output from serial. I think it took us 4 months to get anything working there. And in fact, it required access to NDA documents, so it cannot be upstreamed for others to use, which is quite unfortunate, I think, because serial would be the optimal debugging tool. Obviously, other debugging methods in coreboot exist, but for the reasons you can read for yourself, these were not available to us in an accessible manner. And perhaps you're able to give some guidance for future work for us if you've got experience with this. But nonetheless, we got the board working. I think you can check out the Garrett review to see more information about it. And we will gladly answer any questions during the discussion. But for now, I would like to hand the microphone back to Yusuf to talk about future research plans.
All right, thank you. So that's not the end of what we have planned. There's more to come in the future. So far, Fabian has demonstrated in his thesis that it's generally viable and feasible to design custom suspend implementations in coreboot. But as you might have noticed, it is quite similar to what suspend to disk already does. So the ultimate goal of our project is to design a new suspend mode that combines the advantages of suspend to memory with the benefits of suspend to disk. So what we want to achieve in the end is that we want to have both very fast wake-up times and near zero energy consumption while the system is suspended. And to achieve this, we plan to exploit hybrid CXL storage devices, but all of this is still very early stage work, and there are no results yet, and I can't share too many details of what we're doing right now. So this is like the first project we're working on right now. And the second one, I have already mentioned CXL Global Persistent Flash in the beginning. And so what GPF does is that it flushes the CPU caches to persistent memory as soon as the power supply unit reports a power loss. The PSU is then required to provide just enough residual energy for the system to flush all the data. And again, this is a process that happens in firmware, more precisely in system management mode. So what can we do with that? A simple idea would be to take a process, a operating system process, a user space process, and put all its pages onto persistent CXL attached memory. And then we would have something like a persistent process. But as you can probably imagine, this would cause a severe performance hit. So what if we could design a smart mechanism that only partially moves pages to persistent memory at runtime and leaves the rest to global persistent flash? Perhaps we could add some additional logic in system management mode to be executed on a power loss to help here. So that's kind of the second project we are working on right now. All right, and so that's it mostly for today. What have we seen? Most of the previous firmware-related research has focused on security topics, for good reasons, obviously. But we think that firmware could also be interesting for other systems research areas as well. This is why we created the first coreboot port to an off-the-shelf mainboard on Intel's EagleStream platform with a Sapphire Rapids CPU. And we're currently using that to work on suspend and persistent memory topics. All right. Thank you for listening. That's it from our side.